In this video, we're going to begin the first of our two-part series on classes. We're going to build a POCO class, a plain old class object. Now remember, a class is a recipe for an object. It's a definition of a custom data type, okay? And in the second part, we're going to actually instantiate that class as an object and then be able to manipulate that object. So this will be pretty cool. And I want to just say it this way. Welcome to object-oriented code. So now we're going to take a look at how to build our first class in Java. Now remember that a class is a recipe for an object. Another way to say it is a class is the definition of a custom data type. And classes basically have two main types of things in them. They have fields and they have methods. And the fields are the storage of the class, and the methods are the things that the class can do. Now there's some special case methods that we're going to talk about as we go. One group is called constructors and the other is called getters and setters. So we're going to talk about that as we go through building our first class. So I've created a project called my first class project, as in for the first classes we're building. And we've got a package, and I'm going to create a class called widgets. But first, let me put my header in main. And this is going to be our first, I'm going to call this our first class examples. Okay, so here's main, and we're not really going to work in main yet because we need to build a class that we're going to use. All right, so we're going to go over here to my package and click on that, and I'm going to go up here to class again, and I'm going to hit new Java class, and in here I'm going to call this capitalized widget. Now I do not need a main because this is not going to be executable code. This is a standalone file with a class called widget. Okay, now I'm going to go in here and put in my header. It is the widget class. I'll go ahead and fold that. All right, and this is where I'm going to define a class called widget. Now widget, or well, any class is used to model something in the real world. All right, so we're going to pretend that we sell widgets. Okay, so let's see. One of the things we need to know is how many widgets we have in inventory. Okay, so we're going to build the fields of our class. So we're going to make the fields private because we want to protect these fields from hacking, basically. We don't want people to get into our fields, and we'll talk about that in a minute. We need an integer called widgets on hand. And we're going to need a string for the name of the widget. So we're going to need a private string widget name. Notice I am camel casing all of these fields. Okay, we need a, let's call it a double because this will be money, and we'll call it widget cost. And we're going to need another private double widget price. This is the price we will use for what we sell these widgets to our customer. And that's enough for now. I think you can kind of get the point. Now, there's three access protectors that we've talked about in our videos: public, private, and protected. This is private because we want to control access into those fields. So the next thing we're going to do is begin to define the special case methods for this class. And the first ones we're going to talk about are called the constructors. Now, when we create a variable of type widget, we are instantiating this class. And if you recall from our video discussion, that means that we are creating a memory area the size of a widget and giving it a token name or a variable name that we can operate on. Right now, we are going to set up what happens when you call the word new, when we actually instantiate one of these in memory. So we're going to create the fields, or excuse me, the methods known as constructors. Okay, so typically what I do is I make a multi-line comment like this that says, here's my constructor section. Now I require all of my students to create a minimum of 3 constructors: a default constructor, a partial constructor, and a full constructor. So we're going to do these by hand this one time. And after this, we're going to show you how to auto-generate them and make sure they're correct with the auto-generator. And then I'm going to interject a video on constructor chaining, which is the way you're going to really do it professionally. And there's some slight tweaks to it to save code maintenance, but that'll be a separate video. So let's build first our default constructor. Now our default constructor is when someone doesn't know any of the values with which to initialize our object. So what we're going to say is we're going to say public. Now in Python this would be init, and you'd only get one shot at it. In this case, we can override this method, and constructors all have the name of the object. So public widget, and we're not going to give it any input values at all. So the first thing we're going to do is call its parent super to be proper coding in Java. We're going to call the parent object of everything, which would be object because this is a custom. So this would call the object constructor in the language. So we make a call to super, and then we're going to say this dot widgets on hand, and there it is. So if I enter, it completes it, equals 0, because I want to initialize all of the fields of my class, because the user who's calling this constructor didn't give me anything. Okay, so it's going to be this dot widget name is next, equals, and here I'm going to say no name assigned, just kind of as a default, so nothing was put in. So if I ever see that in my output, something did not get initialized, or it was initialized with this constructor. Okay, notice the IntelliSense knows to help me out, which is great. And this dot and price is the only other one we haven't done. So now I have safely initialized all of my fields. Okay, but now what if the person that's creating this knows, let's say, how many I have on hand and what they're called? Okay, well, that's going to look like this: public widget. Now if I just do this, I'm going to get an error because it's going to say duplicate method. Okay, because it's reading the signatures of these two methods. So in here I need to say, well, I'm going to give you widgets on hand, and I'm going to give you a string called widget name. Okay, so now because I have a different signature, and by the way, it's done by the data type, not the names of the variables. Okay, because I have a signature that isn't nothing, it's int string, it says, okay, you're overriding. All right, now two of them, these two, I'm going to need, because I wasn't given those, so I'm going to completely steal those from there, because I need to initialize all of the fields. However, here I can say this dot widgets on hand equals widgets on hand. Now, the reason, and if I highlight this, notice it knows to highlight that one, okay? Because this refers to this guy, okay? All right, so when I put the this, I'm referring to the field. This is referring to the local variable. When I was going through college, we'd get our heads handed to us if we used the same name. But now the compilers can disambiguate with this. So it's okay to do that because it does really kind of make it more readable. Okay, I can tell that this is going in there. Okay, think of these input parameters as feeding lines to the fields. Okay, and since I'm in the constructor, I'm just going to directly put them there. So in this case, this dot widget name is equal to widget name. And notice it picked it up with the highlighting. So now I have basically kind of this constructor is in between this one and the one we're about to do. All right? Because in the full constructor, we're going to say, oh, they know everything. So we're going to assume that they're going to give us all the values. All right? So, and let's just mark this one as the partial constructor. Okay? And here, this one's going to be the full constructor, meaning the user knows exactly what we want. So I can literally steal the top half of this one because I'm going to be given those, but I'm also going to be given double widget cost, and double widget price. Okay, and all I need to do is kind of complete the work, if you will, and I still need a close on that guy. That gets that colorization work. So this dot widget cost, where is it? Widget cost equals widget cost, and this dot widget price equals widget price. Okay. Now, if I were to auto-generate these, this is the way I would get them. This is not how you would do this in professional coding. We would use what's called constructor chaining, where I would use this one to call this one. Oh, and by the way, I am missing my call to super and my call to super. But again, we'll talk about that in a later video. Okay, it's also faster to generate, but I wanted to show you kind of the full-on way to do it, and so that when you see the other way of doing it, it makes a lot more sense. So this is a default constructor where I am giving safe values to all of my fields because I've been given nothing. Conversely, down here at the bottom, I'm given all the values, so I'm simply putting them in the fields. Here I'm given 2 of them, so I am basically giving those values to the appropriate field and a safe value to the others. All right? The easiest way to do this is to generate the full constructor first, and then this one, and then from this one you copy 2 of them from here and 2 of them from here. Okay? But you can figure out how you like to do that, but those are my constructors. So now what this means is, if I want to build a widget, I can build one by not knowing anything. I can build one if I know everything, and I can build one if I have widgets on hand and the widget name. I cannot build one if I have just the cost, because as a programmer, I have not provided that constructor. That is a design decision that I must make. Okay? I can give as many constructors as I can create unique signature files for the constructor based on the data type, not the variable name in the signature. So I've got one with nothing, I've got int string, and I have int string double double. Okay? I could not make one that was int string double for this one and then int string double for this one, because it would read those doubles and think it was the same. So there are some constraints on how many constructors you can give, but basically the signatures must all be different. And that is true of any overrides that you do on methods. Okay? So basically that's the three forms of the constructors that I'm using. Now, the next thing I'm going to build is called my getters and setters. And these are another special case method in a class that are used because we have encapsulation running, which means all of our fields are private. So there is no way for me to go in and set the value of those fields or get the value of those fields. Now, obviously, I'm going to want to be able to do that. I need to be able to access those fields. So what I need is a publicly accessible method that has the power to go in and affect those fields, but also has the ability to validate me, to make sure that I'm who I say I am, that I'm logged in, that I have the clearance, etc., etc. So we do that through public methods called getters and setters. So what we're going to do is we're going to build some getters and setters for each of these values. And I'm going to put in the comments, basically validation would go here as a comment, because I'm not going to teach validation the first time we build a class. So I'm going to show you the function of these. And again, in future programs, we're going to auto-generate them, but I want you to see them built at least once. So these are going to be public methods because they need to be accessible to anyone that's calling in they'll be validated, but they have to be publicly accessible. So it's going to be public, and the first one I'm going to do is the getter and then the setter for each of these fields. So the getters are a way of reading the value of the field, and the setters are a way of writing the value of the field. So if I give you a getter but not a setter, it's read only. If I give you a setter and not a getter, it's write only. If I give you both, it's read write. If I don't give you either, you're not getting at that field. It might just be an internal field that's set up when I initialize whatever the class is, and you're just never going to get to it. Okay? So, although those kinds of fields are not very useful, we're going to do a getter and setter for the first field, which is widgets on hand. So it's going to be public. It's going to return an integer because that's the data type of the field, and it's going to be called get widgets on hand. Now, because I start with get in camel case, widgets on hand, the W becomes capitalized. Don't let that confuse you. Okay? Because it's a getter and I'm returning a value, I don't need to put anything into it. And I'm going to put the comment here. Validation would go here. Okay? And I don't need the extra E there. So the validation would go there, and then assuming you're validated, we're going to return this dot widgets on hand. And to make sure I type it right, I'm going to use the IntelliSense. Okay, there we go. Now, in this modern compiler, I don't really need this. Okay, because there's nothing to disambiguate in this case because it's going to know it's the field. All right, so that saves me a little bit of typing. And that is the getter for get widgets on hand. Now, when I'm going to set, when I'm going to set the widgets on hand, it's going to be public void because it's a procedure now. I'm not returning a value, and I'm going to call it set widgets on hand. And I'm going to pass it an integer, which is going to be widgets on hand. Notice the W is small, as should the A be. Okay. And again, the user validation would go here to make sure that I'm allowed to set the widgets. But then once I do it, it would be this dot widgets on hand equals widgets on hand. Okay. I'm literally, I love to capitalize that second A. Okay, so that's a getter and setter because first of all, this is a function. It's going to return the number of widgets on hand. So it's returning an int. If I want to double check, yep, it's an int. Okay. The setter is going to accept an integer, make sure I'm allowed to do it, and put that value as the new value for that. Okay. Now, that is a getter and setter for this guy. All right. Now, I'm going to copy and paste to show you how easy it is to get these for the other ones. Because the structure is basically the same. Okay. So this is not going to be widgets on hand. It's going to be widget name, and it's a string. So this is going to return a string, and it's going to be get widget name. Get widget name, and this is going to be set widget name. There we go again. And this is going to be a string. Widget name. And then this is going to be this. Oh, let's just do this one again. This dot widget name equals widget name. Okay, and this is going to be return widget name. Okay, so public string is going to return a string, and it's going to return widget name. It's going to receive a string widget name and set it. So there we go. So now we've done widget, and if you want to, you can say getter setter for widgets on hand. Okay, and then I can say getter setter for widget name. Getter setter for, let's see, this will be widget cost. Okay, now let's see, these are using ints, so I can make those go to doubles pretty quick. So I'll copy that one. So it's going to return a double. It's going to accept a double. And it's going to be get widget cost. It's going to return widget cost. Set widget cost. Widget cost. Widget cost. You just have to be careful when you do this that you're getting everything changed. but the compiler is going to tell you if you get it wrong. All right, so I'm going to return a double, which is widget cost, which is a double. Let's get widget cost, set widget cost, receiving the cost, and setting that into the right field. Okay, and last but not least, because these are both doubles, it makes it easier. So Control C, Control V. No, that's not the one I wanted to copy. I want to copy this, Control C. Put it over there. Still going to do it to me. And this is going to be price. And all I need to do is change the word price on all these. Okay, so now I have my getters and setters for my fields. So I have a way, widget price, widget price, widget price. I'm wondering why that particular one is being colorized and the others are not. Widget price. Let's see. Am I missing something down here? Get widget. Oh, there we go. Price. See if that got it. Yep. So the compiler was even telling me that I was missing part of it, which is a beautiful thing. One thing I want to say about compilers. People get really upset when they see a lot of compiler errors or a lot of red going down the column. It's actually a good thing. It saves you tracing bad code. So if you solve all of your compiler errors quickly, you start to write tighter code. All right. Now, the one method that I always like to do, and I always make sure that all of my students have to use, and that is some sort of a dump method or a display method. So I'm going to say this is my display method for this class. All right. Because I always want to be able to show the state of the object. So because this is a bunch of print statements, I'm just going to paste it in. Okay, and you can see I'm just printing a widget report. Okay, where I'm calling the getters to get me the values safely, and I can just call display widget. So now I have a widget. So now we're going to go into main, where I'm actually going to be able to use this class, but we're going to do that in the next video. So we've built a widget class, and in the second part of this video, we're going to actually use main to use and instantiate those widgets. Okay, now you've seen how to build a class. So in the next video, we're going to instantiate that class. We're going to turn that custom data type template into an actual object. So I'll see you on the other side.